Hello students, now we are going to discuss power in an AC circuit. Okay, we know the formula of power, P is equals to VI, okay, from chapter number 3. And in AC we know that instantaneous EMF is equals to E naught sine omega t, and instantaneous current I naught, I is equals to I naught sine omega t minus phi. It may be omega t in case of purely resistive circuit. In case of inductive circuit and capacitive circuit, it may be plus minus pi by 2. Okay. In other cases in LR circuit, LC circuit, and LCR circuit, it may be some phi, plus phi or minus phi. In general, we will take E is equals to E naught sine omega t, I equals to I naught sine omega t minus phi, means current and EMF have some phase difference. It may be positive or negative, whatever. Okay, means current and EMF have some phase difference. Okay, now it is instantaneous EMF, it is instantaneous current. Then if you want to calculate power, average power, instantaneous current, instantaneous voltage, and instantaneous current, you can put the value here, E naught sine omega t into I naught sine omega t minus phi. Okay, you can take here E naught, I naught, and sine omega t into sine omega t minus phi. It is sine A, sine B. Formula is sine A into sine B 2 times, that will be equals to cos A minus B minus cos A plus B. This is the formula. Okay, but if you see here, it is here 2 is not present, then you can multiply and also you can divide by 2. Then average power will become E naught I naught upon 2 sine A. In place of A it is omega t, in place of B it is omega t minus phi. Here cos A, omega t minus omega t minus omega t plus phi, it will be only phi. Okay, minus cos A plus B, omega t plus omega t minus phi, it will be cos 2 omega t minus phi. Okay, here what you will see, that phi, this term, this cos phi is independent of time. That means it is constant. If initial phase is constant, if the phase difference between I and V is constant, then cos phi is constant no matter. But this cos 2 omega t and phi, it is time dependent. That means the value of this will vary, means somewhere it will be positive and somewhere it will be negative. Okay, because the function of cos is like that. Here positive value, same positive value, that will be equals to sum of these two positive will be equal to this negative value. That means in a complete cycle this term will be 0. Okay, in a complete cycle cos 2 omega t minus phi is 0. Here only will be E naught I naught upon 2 cos phi. This is the formula for average power or instantaneous power. Okay, here it is what, cos phi, because the power depends on the initial phase angle that means this term cos phi is known as power factor, okay, because it is generally power and it is the coefficient, then a cos phi is known as power factor. Okay, now this formula can be changed into another form. P average, we know that P average is equals to E naught I naught upon 2 cos phi. Here E naught upon root 2 into I naught upon root 2 cos phi. Okay, E naught upon root 2 is what? ERMS and IRMS cos phi, means instantaneous power or average power that will be equals to the multiplication of RMS EMF, RMS current and cos phi, where cos phi is the power factor. Okay, where we know that this is a triangle and this is XL minus XC and this is R and this is phi. Here if you try to calculate cos phi, base upon hypotenuse, okay, and you know that this is what? This is Z. Base upon hypotenuse means in place of cos phi you can write here base upon hypotenuse R by Z. In place of Z you can write here, you know very well, that R square plus XL minus XC whole square. Okay, it is cos phi, means power will also depend upon initial phase angle. Okay, means cos phi is equals to R by R square plus XL minus XC whole square. Here if the circuit is purely resistive, what will be the condition? Purely resistive circuit. If the circuit is purely resistive, means no capacitor and no inductor, that means XL and XC will be 0, means here R upon under root R square, between R upon R, that means cos phi is equals to 1, means here phi will be equals to 1. That means if phi is 1, then average power for purely resistive circuit, average power will be equals to ERMS into IRMS. Okay, hope you are getting. But if the circuit is purely inductive or capacitive, that means angle between E and I, will be plus minus pi by 2. In case of inductor, it will be plus pi by 2, and in case of capacitor it will be minus pi by 2. Means phase difference between E and I will be equals to plus or minus pi by 2. In case of plus minus pi by 2, cos pi by 2, it will be 0. Means average power in a complete cycle, average power in the case of inductor and in the case of capacitor, the average power in a complete cycle will be 0. Hope you are getting. Okay, if the circuit is not purely resistive, capacitive or inductive, then it may have some initial phase, and on the basis of initial phase the average power will be different. Okay, you know that initial phase, how we will calculate? Tan phi is equals to XL minus XC upon R. Phi is equals to tan inverse XL minus XC upon R. Okay, or you can calculate here cos phi is equals to R by Z. Simply calculate Z and put the value, you will get the answer. Okay, this is the cos is what? Cos is the power factor. Okay, hope you are understanding, and thanks for watching this video.